Welcome to this video on measures of variation, part 1. After watching this video, you will be able to explain what is meant by measures of spread. You will be able to calculate the range and the standard deviation, and you will be able to explain why standard deviation is a more robust measure of spread than is the range. So let's answer the question, what do we mean by spread? Well, I don't know about you, but when I think of spread, I think of making a sandwich. So in this case, we have somebody making a sandwich and they just put one little squirt of mustard, mayonnaise, ketchup, whatever they're putting on their sandwich in the middle of the bread. As you can see, the spread is all clumped together, so most bites of the sandwich are not going to taste like whatever they're putting on their sandwich. Over here, we have someone who spread out their sandwich spread. And so, as you can see, it's much more evenly distributed so that almost every bite of your sandwich will taste like whatever that spread is. So as you can tell here, the surface of a piece of bread is two-dimensional. You have the x or horizontal axis and the y-axis or the vertical axis. When we're talking about data, we're really only working in one dimension, so we can literally just plot these on a number line. So as you can see here, I've represented some data points on a number line, and I've shown you that these are all grouped or clustered around an average of 5. Over here, you can see also that there is an average of 5, but they're much more spread out or dispersed. So on the left-hand side, we have examples that have smaller spread, and on the right-hand side, we have examples that have a larger spread. And that's literally all we're saying when we're talking about either range or standard deviation. We're asking ourselves the question, how far apart or close together is a set of data? So there are two different ways to mathematically measure spread. One is to calculate the range, and the other one is to calculate the standard deviation. Let's talk about calculating range. The range is the maximum value minus the minimum value. So let's suppose you've taken 5 different exams in a course, and your scores are 79, 85, 64, 95, and 100. What is the range of your exam scores? To answer this question, all you need to know are the highest and the lowest scores. Your lowest score is 64. Your highest score is 100. Therefore, your range is 100 minus 64, or 36. So let's use our sandwich example to explain how range works. In our first example, let's just pretend that we're making a sandwich and we only put 2 little dollops or squirts of mustard, mayonnaise, again, whatever you're putting on your sandwich. That's it, and you stop there. So I could represent this in a one-dimensional way by just putting 2 data points down, one at 3 and one at 7. Doing this, we can calculate mathematically our range of 7 minus 3, or 4. On the other sandwich, or the other piece of bread, let's say that I have a much more homogeneous distribution of, again, whatever we're putting on our sandwich. So if I represented this in a one-dimensional number line, it might look something like this. Again, my range is still the same. My data points go from about 7 to 3, so I still have the range of 4. So let's look at these two pieces of bread. Let's make an assumption that they're going to be on 2 different pieces or 2 different sandwiches. Which one would you actually rather have and eat? Again, assuming the spread is something delicious like peanut butter or mayonnaise or Nutella, something that you enjoy eating. Well, hopefully you would agree that the left piece of bread is going to make a much less delicious sandwich. Why? Well, because most of your bites of that sandwich are not going to contain whatever your spread is, and it's going to be kind of dry. On the right-hand side, you can see that almost every bite of your sandwich is going to have that spread, and it won't be dry, it will be delicious. So hopefully this example explains to you why the range is just really not the best measure of spread, because you can have the same exact range and really have completely different data sets. Let's look at another example to demonstrate why range is not the strongest way to measure spread. So Again, we only use these two numbers to calculate range, the maximum and minimum values. That's it. So let's suppose you're a teacher and you have two grade books for two students. So they have, it looks like a collection of 7 quiz grades. So your first student has a 10, a 9, a 9, a 9, a 10, and an 8. We'll assume that 10 is the maximum here. And then they have one score of 0. Your other student has a much more varied set of quiz scores. They have a 10, a 6, a 7, a 2, a 0, a 0, and a 3. So as you can see from these scores, both students have a maximum of 10, both have a minimum of 0, and so they both have the same range. But are both students' scores equally spread out? To answer this question, let's look at the two students' scores on number lines. Looking at student 1, we can see that all of the data sets, or the data points rather, are clustered over here between 8 and 10, with the exception of this single outlier. For student 2, we can see that these data points are much more dispersed. So which of these students actually has a larger spread? If you answered student 2, you are correct. Again, the range is not a great measure of spread. It's not the best measure of spread because it doesn't give us the full picture. It's only using those two data points, the maximum and the minimum. We need a measure of center that takes into account every single data point. That's where standard deviation comes in. If you read a textbook or you look online, you might encounter an equation for standard deviation that looks something like this. Chances are this looks confusing and intimidating. It may even contain symbols that are unfamiliar to you. The good news is that we will learn a very simple and direct way to calculate the standard deviation. Even better, we will develop a strong understanding of what standard deviation really means. Standard deviation is the average distance from the mean. If you remember nothing else about standard deviation, please remember this definition. Think about how we calculate averages. Usually, we add up a bunch of data, and then we divide that number by the number of data points we have. This is almost the way we calculate standard deviation, with a few important exceptions. We will learn how to calculate standard deviation by using a concrete example. So let's go back to our 5 test scores. First, we're going to graph these values on a number line so we can see the spread of the data. Remember, the standard deviation is the average distance from the mean or the center. So before we begin, we need to find the mean. Remember, to find the mean, we add up all of our data points and divide by the number of data points we have, in this case 5. So we find that the mean of our set of data is 84.6. In the image above, the mean is shown as a triangle. The distance from each data point to the mean will be shown with a different colored arrow. So the different distance from 84.6 to 64 is shown with this blue arrow. Then we have the distance from 84.6 to 79. Then we have the distance from 84.6 to 85, the distance from 84.6 to 95, and the distance from 84.6 to 100. So remember, we want to find the average of these 5 distances. That's what the standard deviation is going to tell us. We want to find the average distance from each data point to the center or the mean of the data. So the easiest way to calculate standard deviation is to create a table. Let's look at the table we have here. The first column is the data point itself, and we are going to represent that by the variable x. So again, x represents the individual data point. We have 5 data points, 64, 79, 85, 95, and 100. Our next column contains the mean or average of the data points. Notice we are using the symbol x bar. That is used to represent our sample mean. In our case, our sample mean is 84.6. Our third column in this table so far is the data point minus the mean. Remember, standard deviation is the average distance from each data point to the mean. So before we can average these data points, we first have to find how far each data point is from the center of the data. So down here we can see that we have that graphically depicted. The first distance is 64 minus 84.6, which gives us negative 20.6. That's the first row. We can continue this process and label the distances. Notice that some of the distances are negative and others are positive because some of our data points are to the left of the mean and some are to the right of the mean. Let's look at this equation that we first introduced when we mentioned standard deviation. Which part of this equation have we now evaluated? Well, we found not 1, not 2, not 3, not 4, but 5 different x minus x bars, or 5 different distances from the mean. Let's continue. So now we have added a fourth column to our chart, which is that we are squaring all of these distances. So you can see in our equation, that would be the next step. First, we find all of these distances from each data point to the mean, and then we need to square those values. And we've done that in this table right here. Well, next you can see that what I've done with all 5 of these values is I've added them together. Well, how did I know to add them? I knew how to do that because of the symbol here. It bears some resemblance to the English letter E, but it actually is the Greek letter which stands for S. It's the capital Greek letter sigma, and in mathematics it stands for summation, sigma summation. So anytime you see the capital letter sigma in mathematics or statistics, it will imply addition or summation. So let's take this value, 801.2, and we're finally going to plug this value into our equation. At this point, we're done with the table. There's no more calculations with the table. The rest of our work has to be done in our equation. So now we have the square root of 801.2 divided by the quantity n minus 1. Well, what is n? Remember, n is the number of data points. Well, how many data points are we working with? Let's count them. We have 1, 2, 3, 4, 5 data points. So therefore, n is equal to 5. Let's plug that in. And at this point, this is a job for a calculator. I used Desmos and free online software and found out that our standard deviation is 14.15 and so on. So this is the standard deviation of our data. So let's discuss what the standard deviation actually means. This means that the standard deviation is approximately 14 points. Notice that I had to round my standard deviation. As you go through and work these problems, you may be given specific directions about how to round. Otherwise, you're going to have to use your common sense. Also, it's important to understand that the units of standard deviation are the same as the units of the original data. In our example, we were looking at test scores. Our original units were points. We assumed that students could earn between 0 and 100 points on each test. Therefore, the units of standard deviation are also points.